My group focuses on understanding the relationship between conformational disorder and regulation of catalytic processes. And we mostly focus on biological catalysts and nanoparticle catalysts. Our research on biological catalyst or enzyme is important because understanding how enzymes are regulated will help us designing novel drugs, and we're particularly focusing on systems that are involved in development of bacterial infection. Therefore, we will be able to hopefully address the problem of antimicrobial resistance, and we are also looking at enzymes that are involved in development of cancer. So ideally our work will help addressing the problem of developing new anti-cancer therapeutics. And for what concerns our nanoparticle work, we are of course we're trying to understand how nanoparticle catalysis is regulated so that we can develop more efficient and more selective catalysts for industrial applications. Our group is very question driven. So we do use a lot of NMR spectroscopy because that's where my training is in, but we try to use whatever investigation technique is needed in order to address our question. So as such, we do a lot of theoretical calculations. We use a lot of spectroscopic technique on top of NMR. So we do some X-ray, we do some mass spec, and of course we tend to prepare our own enzyme samples. So we do a lot of molecular biology, protein purification, and so on. I feel there is not one single way to be a good advisor. There are different types of students, and they need different types of stimuli or stimuli in order to be productive and excited about research. So you really need, I think you really need to tailor your advisor style on the type of student that you're facing. There are some students that need you to be in the lab and be more hands-on, and other that need only you to show them the direction, and then they will be able to, and they will feel even more free, right, to choose their own approach to learning. So I think you have to be a different advisor for different students. That's my approach. As I was mentioning earlier, we are very question-driven. So, and I'm an expert in NMR spectroscopy, but of course, in order for my student to be able to have access and be proficient with other investigation technique, we need collaborations with experts in these other techniques. So we collaborate a lot with the X-ray facility across the street in BBMB. We have collaboration with Dr. Slowing lab in the Ames lab for our nanoparticle work, and they are helping us a lot in the synthesis and characterization of nanoparticle catalysts. We are collaborating with the Julian Roche group across the street in BBMB. He's an expert in high pressure NMR, and we use high pressure NMR to shift conformational equilibria in proteins. And so yeah, so we do have a lot of, we collaborate with the mass spec facility for our mass spectrometry analysis. So we do have a lot of collaboration, and they're definitely improving the quality of the research in the group. I feel ISU is a very supportive university, and especially the chemistry department has been very supportive toward young PIs like me. And in addition, ISU is a very sweet spot for structural biologists. There are several initiatives on campus to expand the structural biology portfolio, and there are a lot of NMR spectroscopy groups, so it's a very good place to be an NMR spectroscopist.